To help us understand competitive neurons better, it's useful to look again at neuron operation, but from a slightly different perspective than we did before. You might remember that the inputs to the neuron form a vector, as do the weights. For example, consider the two-input neuron now shown on the screen. Before the squashing function is applied, the result can be calculated as shown. The input and weight vectors are also shown in vector format. Now there are two ways of multiplying vectors together. The vector dot product, denoted as w dot I, and the vector cross product, denoted as w cross I. The formula for the dot product involves multiplying each component of vector A with a corresponding component of vector B, and then adding the results together. And in fact, this gives the familiar formula for the neuron output, and means that the output before the squashing function is equal to I dot W, as shown on the screen. But what does the dot product actually mean? Well, an alternative formula for the dot product is that I dot W is equal to the magnitude of I times the magnitude of W times the cosine of the angle between the two vectors. This means that the dot product is maximum when the angle between the vectors is 0. In other words, when the vectors are aligned. This is because of the properties of the cosine, which is a maximum when the angle is 0, as shown on the screen. In other words, the dot product is a measure of how similar the two vectors are. In fact, if we normalize the vectors so that they both have a length or magnitude of 1 unit, then the dot product would be 1 when they're perfectly aligned and 0 when they're perpendicular to each other. The vectors can be normalized by dividing them by their magnitude, as shown on the screen. But what's this got to do with training? Well, in competitive neuron training, what we do first is to measure how close each weight vector is to the input vector, in other words, the pattern. And we do this by calculating a normal output, in other words, the dot product. What we actually do by training a winning neuron is to change the weights so that the dot product becomes larger. In other words, change the weights so that the weight vector is more aligned with the input vector and will give an even higher output when it sees that input again.